Okay, so far, so good. Ionic compounds don't seem that tricky to name. Well, that is until you meet up with what's called a transition metal. Your transition metals are those metals that are here in the middle of the table that we ignored in the first video. These metals sometimes will give up one number of valence electrons, and another time they could give up another number, hence transition. So what I did is I gave you a couple of examples here. There are typically certain metals that will show up more on a test or on example problems than others because we use them more. Check with your teacher or your professor what they need you to memorize. So once again, in the first video I told you need to memorize the names and the correct spelling of at least the first 56 elements, I would say. Then, on top of that, anywhere with the transition metals where there is more than one charge that that metal could have, usually there's a certain group that your professor or teacher might want you to memorize. So check with them or check the textbook. So, let's take a look. Well, what we're going to do here is let's take a look at these first two compounds. Both contain iron and oxygen, but you see different ratios of the two elements. Well, that's because they are two separate compounds, because in the first compound FeO, I have one iron to one oxygen atom, and in the second compound formula, I have two iron atoms for every three oxygens. So they're different compounds and they get different names. Now, starts out the same as before. I write the entire metal name, so it is iron. And I do write the non-metal name and I change the ending to IDE. So it's iron oxide. But now I have to indicate which of the iron charges that this iron is. If you memorize that iron has to either be +2 or +3, that's probably going to make your life a little easier. The other thing that's going to make your life easier is if you go ahead and you label, right? We said we're not worried about the noble gases, but the halogens, which are next to the noble gases, when they combine with metals, they gain 1 electron per atom for a -1 charge. The next column is -2 charge. The next column -3. So, if I go back and I know I have oxygen, and the charge on oxygen is a -2, and it's a 1-to-1 ratio of oxygen to iron, this must have a charge for the iron of +2. In other words, the iron atom gave up 2 electrons and the oxygen took the 2 electrons. Now, to indicate that this is the +2 charge for for iron, we use a Roman numeral of 2. You put the Roman numeral in parentheses, and you put it right between the metal name and the non-metal name with the changing to IDE. Let's look at the second one. Well, I follow the same thing in that oxygen is still always a -2 because it's bonding with a metal. And now I have 3 oxygen atoms, each gaining 2 electrons for a total of -6, and they had to come from these 2 iron atoms. Well, if I have a -6 and I divide it by 2, that would be obviously -3, but remember, if oxygen is gaining a total of 6 electrons, then the iron gave away a total of 6. So 6 divided by 2, that must mean that this is iron 3. So now I'm dealing with iron 3 oxide. So you do have to do a little bit of problem solving to figure out what charge it is. But of course, you're going to make your life so much easier because you're going to memorize the possible charges for the transition elements, or at least the ones that are used most often. Okay, let's do another example here. CuCl and then CuCl2. Cu is copper, and Cl, if the element is chlorine, but we change the ending to IDE, so it's a copper chloride. But once again, I need to know what the oxidation or the charge would be for the copper. Well, if you memorized, copper is only +1 or +2. Those are our choices. Chlorine, of course, being a halogen, when it's bonding with a metal, is always a -1 charge. So, if this is -1, and I have a 1-to-1 ratio, that meant this copper has to be +1. And we indicate that this is copper giving up 1 electron by putting the Roman numeral 1 in parentheses between the metal and the non-metal. If we take a look at the next one, chlorine is still -1, but now I have 2 chlorines for a total of -2. That meant however many coppers I have, that would have to, of course, total up to giving up 2 electrons. Well, there's only 1 copper atom, so it's got to be copper 2 chloride. This is definitely a little bit more interesting than the simple ionic compounds, but you can do it, but you have to memorize some information in order to see it and be successful. Okay? And what I want to point out to you one more time is, if I'm dealing with copper, for example, with +1, then that is copper with a Roman numeral 1. Copper 2+ is copper Roman numeral 2, etc. Okay, so very important that you understand that the Roman numeral ties into the charge of the metal. I'll say it again, it's that important. The Roman numeral in the name ties into the charge on the metal. It is not the number of times that the metal appears in the formula. Take some time, work with the information, go back to your book, do practice where the solutions are in front of you, listen to the video again if you need to, and good luck.